Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Imagine this: a developer spends an entire weekend preparing a web application for production. First, they launch EC2 instances, then configure security groups, then create a load balancer, then build an auto-scaling group, then configure health checks, then connect monitoring, then create the deployment process. Sunday night arrives. The infrastructure is finally running. Monday morning, the application fails its health checks because one security group rule was configured incorrectly. The developer didn't spend the weekend building application features. They spent it assembling infrastructure. That's the problem AWS Elastic Beanstalk is designed to reduce. With Elastic Beanstalk, you provide your application, choose a supported platform, configure the environment, and let the service automate much of the common infrastructure provisioning and environment management. EC2 still exists. Load balancing can still exist. Auto-scaling can still exist. Security groups still exist. Monitoring still exists. And configuration mistakes are still possible. The difference is that you don't have to assemble every common component manually. That's the promise of Elastic Beanstalk. You focus more on deploying the application. AWS automates more of the environment around it. By the end of this video, you'll be able to explain what Elastic Beanstalk is and when to choose it over manual EC2, Lambda, or containers. You'll deploy a sample web app with the AWS console and the command line. And you'll be able to map out the architecture it creates and sidestep the #1 beginner mistake. This is the 7th piece of our cloud practitioner journey. We've covered EC2, Lambda, and containers. Now, Elastic Beanstalk builds directly on EC2 and load balancing concepts you already know. And next up is auto-scaling, the engine behind its scaling. Let's understand the problem Elastic Beanstalk is trying to solve. Suppose you've built a web application and want to deploy it on AWS. You could start with EC2, launch instances, configure the operating system, install your runtime, deploy the application, configure security groups, add a load balancer if the architecture needs one, create an auto-scaling group, configure health checks, set up monitoring, create deployment procedures, and plan how the environment will be updated over time. None of those tasks are necessarily wrong. Sometimes that level of control is exactly what you need. But if your goal is simply deploy my supported web application reliably, you may be spending a lot of time assembling infrastructure instead of working on the application. Elastic Beanstalk provides a managed path through that common deployment problem. You provide the application, choose a supported platform, configure the environment, and Elastic Beanstalk automates much of the common provisioning and environment management work. The underlying AWS services don't disappear. Beanstalk coordinates them for you. That's the difference. Think of it as the difference between renting raw building blocks and hiring a managed crew. With EC2 directly, you're renting compute and storage, then assembling the load balancer, scaling, and security yourself. With Elastic Beanstalk, you hand over your application code and a platform choice, and it assembles and manages the resources for you. Same underlying AWS services, different division of labor. Let's lock that in. With Direct EC2, you choose and assemble the environment components yourself. Instances, load balancing when needed, auto-scaling, network rules, deployment steps, and monitoring. With Elastic Beanstalk, you provide the application, choose a platform, and configure the environment. Elastic Beanstalk provisions and manages the common environment resources for you. The resources still run in your AWS account, contribute to your bill, and need thoughtful security and application configuration. The difference is the amount of infrastructure assembly you have to do yourself. As you work with Elastic Beanstalk, you'll encounter a few recurring concepts. An application is a logical home for your code versions. An environment is the actual running collection of AWS resources. A platform captures the language and server stack your code needs. And some environments include a tier choice for web versus background work. These are useful mental labels, not a rigid four-part model, but they come up constantly. Elastic Beanstalk supports applications developed in Go, Java, .NET, Node.js, PHP, Python, and Ruby. It also supports Docker containers, so you can package your application with its dependencies when a managed language platform is not the right fit. A platform is more than a language name. It includes the operating system, runtime, web server, or application server, and Elastic Beanstalk components that run your app. Elastic Beanstalk regularly releases platform updates. You can configure managed platform updates to apply supported patch and minor updates during a maintenance window. But do not assume every update is automatic or risk-free. Test application compatibility, choose an update policy, and remember that major platform branch changes still require deliberate planning. Elastic Beanstalk reduces platform maintenance work. It does not remove your responsibility for application dependencies, configuration, and security decisions. Now let's walk through what a typical Elastic Beanstalk deployment looks like in the AWS Management Console. Open the AWS console and search for Elastic Beanstalk. Start the workflow to create a new application and environment. First, give the application a meaningful name. Remember, the application is the logical home for your application versions and environments. Next, choose the environment type appropriate for the workload. For a web application, you're typically creating a web server environment. Then choose your platform. That might be Python, Node.js, Java, .NET, PHP, Ruby, Go, or Docker. Choose a currently supported platform branch that matches your application. Next, provide the application code. For a first lab, you can use AWS sample code if the console offers it, or upload your own valid source bundle. Then review the environment configuration. This is where you start seeing what Elastic Beanstalk actually manages. Depending on the environment type and configuration, you'll make choices affecting compute, instance types, capacity, networking, security, load balancing, scaling, monitoring, and deployment behavior. For a simple learning environment, you might start with a single instance configuration to reduce complexity and cost. For an architecture requiring higher availability and scaling, you would evaluate a load-balanced environment instead. Review the service permissions and EC2 instance permissions required by the environment. Review your VPC and subnet choices if networking configuration is exposed in your workflow. Then create the environment. Now watch what happens. Elastic Beanstalk begins provisioning the resources required by the configuration you selected. Open the environment events. You'll see the environment being created step by step. Once the environment becomes healthy, open the application's URL. Your application is running, but don't stop there. Go look at the AWS resources behind it. Find the EC2 instance. Look at its security groups. If you created a load-balanced environment, inspect the load balancer and auto-scaling group. That's the most important part of this lab. Don't walk away thinking, Beanstalk ran my application somehow. Walk away thinking, Beanstalk created and manages an AWS environment for my application. That's the mental model you want. The AWS console is great for learning, but repeatable deployments often benefit from command-line tooling. Elastic Beanstalk provides the EB-CLI. Once the EB-CLI is installed and your AWS credentials and region are configured appropriately, open a terminal in your application directory. A typical workflow begins with ebinit. This initializes the current project for Elastic Beanstalk and associates it with an application and platform configuration. Next, ebcreate. This creates an Elastic Beanstalk environment. Depending on your configuration and command options, Beanstalk provisions the resources required by that environment and deploys your application. Want to check the environment? Use ebstatus. This gives you information about the environment and its current state. Make a change to your application. Then deploy the new version with ebdeploy. Need logs for troubleshooting? Use eblogs. And if you want to open the deployed application in your browser,ebopen. So the basic workflow is ebinit, ebcreate ebstatus, ebdeploy, eblogs, ebopen. Don't memorize every command flag. Options and behavior can change between CLI versions and platforms. Use the current AWS documentation when building a real deployment. What matters is the workflow. Initialize, create, inspect, deploy, troubleshoot. Now, your deployment isn't only something you can click through manually. It can become part of a repeatable development and automation process. Quick checkpoint. You run. ebcreate Elastic Beanstalk builds a standard web environment. Your application comes online. What AWS service commonly provides the actual compute run in that application code? Amazon EC2. Elastic Beanstalk is the managed deployment and environment layer. In a typical Elastic Beanstalk web environment, your application runs on EC2 instances provisioned as part of that environment. In a load-balanced, scalable environment, those instances can be part of an auto-scaling group. A load balancer can distribute incoming requests across the healthy instances. A worker environment uses a different pattern. EC2 instances process background work delivered through Amazon SQS. So remember the architecture distinction. Elastic Beanstalk manages the application environment. EC2 commonly provides the compute underneath it. This is why Elastic Beanstalk isn't a magical replacement for EC2. It's a higher-level managed service that can provision and coordinate EC2 and other AWS resources on your behalf. Here is a common load-balanced web environment in Elastic Beanstalk. A load balancer receives incoming traffic and routes it to EC2 instances in an auto-scaling group. Elastic Beanstalk can monitor environment health and use configured scaling policies to adjust capacity. Security groups control traffic between the load balancer, the instances, and other services. If you deploy this environment inside a VPC, you choose the subnets and network design. A typical production architecture might place a public-facing load balancer in public subnets and the application instances in private subnets. But that is an architectural choice, not an automatic rule. Elastic Beanstalk also supports other environment types. A single instance environment has one EC2 instance and no load balancer. A worker environment processes tasks from SQS and does not use a public web load balancer. So remember the principle. Elastic Beanstalk provisions the resources that match the environment type and configuration you select. Here is the trap that trips up beginners and exam takers alike. Elastic Beanstalk is not a magical black box. It does not make EC2, load balancing, auto-scaling, monitoring, networking, or IAM disappear. It coordinates those services into an application environment. The resources run in your AWS account. They affect your bill, and you can inspect them in the AWS console. Elastic Beanstalk manages much of the environment lifecycle, while you remain responsible for your application code, configuration, access controls, data handling, and architecture choices. That shared responsibility distinction matters. If something breaks, look under the hood. Check environment events, health, logs, instances, load balancer, health checks, security groups, and the application itself. For the exam, remember, Elastic Beanstalk manages an environment built from AWS resources. It is not the underlying compute service that runs your code. The difference is not that Elastic Beanstalk removes every decision. The difference is that it gives you one deployment workflow instead of requiring you to assemble the common infrastructure components individually. With a manual EC2 deployment, you design and connect the instances, load balancing, auto-scaling, health checks, deployment process, and monitoring yourself. With Elastic Beanstalk, you upload an application version, choose a platform and environment configuration, and let the service provision the standard environment resources. You still need to make good choices about IAM, networking, environment variables, database connections, deployment policy, monitoring, and cost. Elastic Beanstalk speeds up the common path. It does not replace architecture. So when is Elastic Beanstalk actually a good choice? Start with the application. Suppose you have a traditional web application or API built on a platform Elastic Beanstalk supports. You want a repeatable deployment process, health monitoring, environment management, configurable scaling, managed platform maintenance options, and integration with common AWS infrastructure such as EC2, load balancing, auto-scaling, security groups, and CloudWatch. But you don't want to manually assemble every infrastructure component yourself. That's a strong Elastic Beanstalk candidate. It's especially useful when teams need multiple application environments. For example, development, testing, staging, and production. Each environment can have its own configuration and application version while following a consistent deployment model. Elastic Beanstalk is also attractive when you want more of a traditional application server model than Lambda provides, but don't need the orchestration complexity of a full container platform. But here's an important qualifier. Managed does not mean responsibility-free. Elastic Beanstalk can automate common environment provisioning, deployment, health monitoring, configured scaling behavior, and supported platform maintenance workflows. You still own your application code, application dependencies, configuration, IAM decisions, data protection, secret handling, networking choices, compatibility testing, and the architecture surrounding the environment. So use Elastic Beanstalk when the application fits the managed platform model and you want AWS to automate more of the environment lifecycle. Don't choose it simply because you want AWS to manage everything. Elastic Beanstalk is not always the right tool. If your workload requires deep host customization, a platform Elastic Beanstalk does not support specialized hardware or a complex container platform with advanced orchestration patterns. Another service may fit better. Depending on the workload, compare Direct EC2, ECS, EKS, AWS AppRunner, or another managed service. If the workload is naturally event-driven and made of short, independent units of work, Lambda may be a simpler option. But do not assume Lambda is automatically cheaper. Compare traffic shape, duration, latency, availability, connected services, and operational effort. Elastic Beanstalk is a strong option when you want a managed deployment path for a supported web application, not when you need every layer of the platform to be custom. Let's check that boundary. Name one situation where Elastic Beanstalk may not be the best fit. For example, you need deep operating system customization, a platform Elastic Beanstalk does not support, a complex Kubernetes-style container environment, or a short event-driven workload that is better expressed as Lambda. The goal is not to avoid Elastic Beanstalk. The goal is to choose it when its managed environment model matches the application you need to run. One major reason to use Elastic Beanstalk is that you can create separate environments for development, staging, and production. Each environment can run a different application version, use different configuration settings, and be created or terminated independently. A staging environment, for example, can test a new version before you deploy it to production. But separate environments are not automatically isolated from everything else. You might intentionally connect them to the same VPC, identity system, shared service, or external database. Design those dependencies carefully. For production data, keep the database lifecycle independent from short-lived test environments. The goal is not merely to create multiple environments. The goal is to create safe boundaries between application versions, configuration, and data. Elastic Beanstalk gives you managed defaults. But sometimes your application needs additional environment configuration. One mechanism is on ebextensions. In the root of your application source bundle, you can create a folder named ebextensions. Inside that folder, configuration files use the config extension. Those files contain valid YAML or JSON. They can be used to configure Elastic Beanstalk environment options, customize instances, run configuration logic, and define certain additional AWS resources through CloudFormation. That gives you a lot of flexibility. But it also introduces risk. A formatting error or incompatible configuration can cause an environment deployment to fail. Treat .ebextensions like infrastructure configuration. Version control it. Review it. Test it. And validate changes in a development environment before applying them to production. There's also an architecture lesson here. Use these customizations sparingly. If your Elastic Beanstalk deployment starts requiring extensive operating system modifications, complicated bootstrap logic, unusual host configuration, and large amounts of custom infrastructure code, ask yourself, am I still benefiting from the Elastic Beanstalk abstraction? Sometimes the answer is yes, but sometimes heavy customization is a signal that Direct EC2, containers, or another platform may fit the workload better. Managed services provide the most value when your application fits reasonably well inside their intended operating model. Don't turn a managed platform into manually managed infrastructure with extra steps. Let's make this concrete with a tiny Python Flask application. For a teaching example, The application code can live in app.py, and requirements.txt can list Flask and any other Python dependencies. But a working Elastic Beanstalk source bundle also needs to match the platform's current deployment expectations, the correct application entry point, a supported runtime version, and the required project structure. For a simple Flask app, that may mean using the platform's expected WSGI entry point, or including a proc file that tells the platform how to start the application. Check the current Python platform documentation before you build. The lesson is not that every Python web app is always 2 files. The lesson is that Elastic Beanstalk can provision the environment once you provide a valid application bundle for the platform you selected. Here is the shape of a minimal Flask deployment bundle. You need application code, a dependency file such as requirements.txt, and a platform-compatible way for Elastic Beanstalk to locate and start the application. Use a supported Python platform version, pin the dependencies your project needs, and confirm the expected application entry point. Elastic Beanstalk can install the declared dependencies and deploy the application bundle. But application configuration is still your responsibility. You must define environment properties, database connection settings, secret handling, logging, health checks, and any custom networking or startup behavior your app requires. Think of Elastic Beanstalk as the managed environment around your application, not as a substitute for a valid application deployment contract. In a load-balanced, scalable Elastic Beanstalk environment, you can use EC2 autoscaling to adjust capacity as demand changes. You configure minimum and maximum instance counts, then choose scaling triggers or policies that match the workload. When demand rises, the auto-scaling group can add instances. When demand falls, it can remove instances while respecting the minimum capacity you set. The load balancer routes traffic across healthy instances. Health checks matter because new instances must become healthy before they should receive application traffic. A single instance environment is different. It has one EC2 instance and does not scale out for traffic spikes. Choose the environment type deliberately based on the availability, traffic, and cost requirements of the application. Recall check. What does a load-balanced, scalable, Elastic Beanstalk environment use to handle traffic spikes? An EC2 auto-scaling group with configured scaling policies can add or remove instances, while a load balancer distributes incoming traffic across healthy instances. Remember the qualifier. This applies to a load-balanced, scalable environment. A single instance environment does not add more instances when demand increases. Elastic Beanstalk can be part of an architecture that meets regulatory and compliance requirements, and AWS assesses the service under multiple AWS compliance programs. But an AWS service being in scope does not make your application automatically compliant. You are still responsible for how your application handles data, how you configure IAM, encryption, logging, network access, backups, monitoring, patch management, and the AWS services connected to the environment. You must also meet the laws, contractual requirements, and internal controls that apply to your organization. If your application uses Amazon RDS, treat it as a separately configured managed database service. It has its own security groups, encryption, backup, access control, and lifecycle decisions. Do not describe it as simply running inside the same Elastic Beanstalk boundary. Convenience does not remove responsibility. Elastic Beanstalk helps create and operate the application environment. You must still design it securely. 3 mistakes to avoid. First, do not tie production data to the lifecycle of a disposable application environment. If Elastic Beanstalk creates a database inside an environment, terminating or rebuilding that environment can put the database at risk. For production, use a separately managed, long-lived database and connect the environment to it deliberately. Second, every resource Elastic Beanstalk provisions runs in your AWS account and can add cost. EC2, load balancing, storage, logging, databases, data transfer, public IPv4 addresses, and other supporting services may all contribute to the bill. Third, configure environment properties explicitly and protect secrets properly. Use environment properties for non-sensitive configuration. Store passwords, tokens, and other sensitive values in a managed secret store, then grant the application only the permissions it needs to retrieve them. Elastic Beanstalk and Lambda solve different workload problems. Elastic Beanstalk is a managed deployment and environment service for supported web applications. It commonly runs application code on EC2 instances, which can be appropriate for a service that is continuously available, needs a traditional web server model, or requires a supported runtime environment that stays ready to receive traffic. Lambda runs event-driven code. It is a strong candidate for short, independent tasks, such as processing file uploads, handling queue messages, or responding to API events. Do not choose by slogan. Lambda is not automatically cheaper, and Elastic Beanstalk is not automatically better for every web application. Compare workload duration, traffic shape, latency needs, platform control, connected services, and total cost. Elastic Beanstalk supports Docker, so it can absolutely run containerized applications. But don't confuse Docker support with full container orchestration. Elastic Beanstalk is designed around managed application environments. ECS and EKS are designed around orchestrating containerized workloads. For a relatively straightforward containerized web application, Elastic Beanstalk may provide a convenient deployment path. But as the architecture becomes more complex, the decision changes. Imagine you now have many independently deployed services. Each service scales differently. They need advanced service discovery, sidecar containers, specialized scheduling, more sophisticated deployment patterns, or Kubernetes-specific APIs and tooling. At that point, ECS or EKS usually becomes the more natural orchestration platform. The distinction isn't one container equals Beanstalk. Many containers equals ECS. There isn't a magic number. The distinction is about the capabilities the architecture requires. Ask, do I mainly need a managed environment for deploying my application? Or, do I need a platform designed specifically for orchestrating container workloads? If you need the second, evaluate ECS or EKS. So remember, Elastic Beanstalk supports Docker. It is not a general-purpose replacement for ECS or EKS. For Cloud Practitioner, remember this model. Elastic Beanstalk is commonly described as a platform as a service, or PaaS. You upload a supported application version and choose environment settings. Elastic Beanstalk provisions and manages the environment resources that run the application. In a typical load-balanced web environment, those resources can include EC2 instances, an auto-scaling group, a load balancer, security groups, health monitoring, and supporting services. Other environment types use different resource combinations. Elastic Beanstalk itself has no additional service charge. You pay for the underlying AWS resources your application consumes. And if an exam question contrasts Elastic Beanstalk with Lambda, remember the core distinction. Elastic Beanstalk manages an application environment built from AWS resources. Lambda runs event-driven code without you managing servers. When you upload your code to a typical load-balanced Elastic Beanstalk web environment, what core infrastructure can Elastic Beanstalk provision for you? EC2 instances, an auto-scaling group, a load balancer, security groups, health monitoring, and supporting AWS resources based on the configuration you choose. The exact resources vary by environment type. A single instance environment, for example, uses one EC2 instance and no load balancer. That is why it is important to understand the environment you created, not just the Elastic Beanstalk service name. When you update your application, Elastic Beanstalk gives you several deployment policies that trade speed, capacity, cost, and risk differently. An all-at-once deployment is fast, but every instance can be out of service briefly. A rolling deployment updates instances in batches, which reduces available capacity while each batch is updated. A rolling deployment with an additional batch preserves capacity by launching extra instances first. Immutable and traffic-splitting deployments launch a fresh set of instances running the new version. Traffic splitting can send only a percentage of users to the new version first, which supports canary testing. Health checks are critical. A failed deployment does not always mean a perfect automatic rollback to one clean state. The outcome depends on the policy and the deployment stage. Monitor the environment, investigate failures, and be ready to redeploy a known good application version. Choose the policy that matches the availability requirements and risk tolerance of the application. Sometimes an application needs more than the default environment. With a valid .config file inside the ebextensions folder, you can use the Resources section to define additional AWS resources supported by CloudFormation. For example, you could declare an S3 bucket or an IAM-related resource that your application needs. When Elastic Beanstalk creates or updates the environment, CloudFormation can create those declared resources alongside it. Use this feature carefully. Resources created as part of an environment may be affected by environment updates or termination, depending on how they are defined. Do not attach irreplaceable production data to a short-lived application environment without a clear lifecycle and backup plan. Open Elastic Beanstalk in the AWS console. Select your environment, then find the Health and Monitoring view. The exact menu labels can vary, but you'll see health status, recent events, and CloudWatch metrics. That dashboard is your first stop when something looks off. Elastic Beanstalk has no additional service fee. You pay for the AWS resources your application consumes. That can include EC2 instances, load balancers, EBS storage, CloudWatch logs and metrics, RDS databases, S3 storage, data transfer, public IPv4 addresses, NAT gateways, and other supporting services, depending on your architecture. The important lesson is not simply Beanstalk is free. The Elastic Beanstalk control layer has no separate charge, but a production environment can still cost money because the underlying resources run in your account. Before you launch, model the architecture in the AWS pricing calculator, set a budget, and make sure you understand which resources remain after an environment is terminated. Let's test something more important than memorizing a pricing sentence. True or false? If you terminate an Elastic Beanstalk environment, You can assume every connected AWS resource and all application data are automatically and safely removed with it. False. This is why resource lifecycle matters. Some resources belong directly to the environment. Other resources may exist independently. Your application might connect to an external RDS database, an S3 bucket, a secret store, a shared VPC, a DNS record, or another AWS service that has its own lifecycle. You should never assume that deleting the application environment automatically handles every connected resource exactly the way you want. The opposite risk matters too. If important stateful resources are tightly coupled to a disposable environment, rebuilding or terminating that environment can create data loss risk. That's why production databases and other critical persistent data should have deliberate lifecycle, retention, backup, and recovery plans. Before terminating an environment, ask, what will Beanstalk remove? What will remain? Where is my persistent data? And what does the application still depend on? That's a much more important production habit than memorizing which button deletes the environment. Let's lock in the 3 ideas from this lesson. First, Elastic Beanstalk is a managed application deployment and environment service. You provide a supported application bundle, choose a platform and environment configuration, and Elastic Beanstalk provisions the common AWS resources needed to run it. Second, it is a strong option for standard web applications when you want a managed deployment path without assembling every environment component manually. It is less suitable when the workload needs deep host customization, a more specialized container platform, or a different serverless execution model. Third, the underlying resources remain in your AWS account. You pay for them, can inspect them, and share responsibility for their secure configuration, application code, data, and compliance outcomes. Elastic Beanstalk reduces infrastructure assembly. It does not eliminate architecture. You've now seen what Elastic Beanstalk actually does. It doesn't eliminate EC2. It doesn't eliminate load balancing. It doesn't eliminate auto-scaling. And it doesn't eliminate your security or architecture responsibilities. It gives you a managed deployment and environment layer that can coordinate those AWS resources around your application. Now turn this lesson into something you can show. Build a small web application. Deploy it with Elastic Beanstalk. Start with a simple environment. Then inspect what AWS created underneath it. Find the EC2 instance. Inspect the security groups. Review the environment events. Open the CloudWatch metrics and logs. Then, if your budget allows, create a load-balanced environment and inspect the auto-scaling group and load balancer. Make one application change and deploy a new version. Break something intentionally in a safe lab environment. Troubleshoot it. Then document what Beanstalk managed, what AWS resources existed underneath it, what you were still responsible for, and when you would choose Elastic Beanstalk instead of direct EC2, Lambda, ECS, or EKS. That's a portfolio project, and it prepares you perfectly for the next lesson. Because one of the most important mechanisms underneath a scalable Elastic Beanstalk environment is EC2 auto-scaling. In Part 8, we'll break down how auto-scaling groups work, how minimum, desired, and maximum capacity interact, how scaling policies react to demand, and how AWS replaces unhealthy instances. If this series is helping you prepare for cloud practitioner or build practical AWS skills, subscribe to Hired in IT and continue with the rest of the AWS series. And remember, careers aren't built by watching videos. They're built by applying what you learn. Build it, break it, troubleshoot it, Document it. Then explain why you designed it that way. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities. If this series is moving your career forward, subscribe to Hired in IT for more certification guides. Drop your Elastic Beanstalk questions in the comments. I read them. And keep watching the rest of the AWS Cloud Practitioner playlist. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.